Hello students, now we will discuss about the common collector amplifier. So in order to understand the common collector amplifier, student able to perform common collector characteristics, VI characteristics, then only he will be able to understand the common emitter amplifier characteristics. So come to the experiment. The aim of the experiment is, here also we are observing the frequency response characteristics of the CC amplifier. And to perform this experiment, we need the components regulated power supply. So this is the regulated power supply we have. In this regulated power supply, student able to understand the how much voltage we need to apply. Means generally for these electronic circuits we will apply 12 volts, and you can observe the voltage. And this is the current now. We can put in current. We can observe the current, and this is plus minus. Like we have dual channels will be there. Power supply in order to apply. This is about the regulated power supply. And next, cathode oscilloscope, CRO, shortly we are calling it as, in order to observe the input and output waveforms. CRO, and this is function generator. In order to give the input signal to the function generator, we are using the function generator. It consists of different elementary signals we have: square, sinusoidal, and triangular signal. Basically, we will give sinusoidal signal as the input to this particular analog electronic circuits. So this is the circuit diagram we have. This is the general circuit diagram we have. So this is input signal, source voltage we are calling it as, and the particular capacitor is connected to the base terminal. So we will call it as CB, because the capacitor is connected to the base terminal, which is a 10 microfarad we have. And these R1 and R2 will provide a voltage divider bias in order to make the transistor in active region. And this is a VC we have, the 12 volts we have applied here, collector voltage. And this is the collector terminal we have, and this is the emitter terminal we have represented here. RE is the emitter resistance, and CE is the bypass capacitor we have, CE, output capacitor. In order to connect the multi-stage amplifiers, we are using this particular capacitor here. So this is the input capacitor and this is the output capacitor. So these two are acts as a coupling capacitors, CB and CE. Here we have coupling capacitors. Whenever we want to connect multi-stage amplifiers, we are connecting the multi-stage to this particular capacitor. So what is the purpose of this capacitor is nothing but whatever the input voltage we have applied, this input voltage is sinusoidal signal, means time varying signal. So directly it cannot directly apply to the here. So it will charge initially, then only it will reach to the base terminal. So this is the common collector amplifier. The another name for common collector is also called as emitter follower, means it provides unity gain. And you have two types of configurations, PNP configuration and NPN configuration. So either you can use NPN configuration you can use, or PNP configuration you use. Mostly we will go for NPN configuration. We are connecting the NPN configuration. And coming to the procedure, we need to connect the circuit as per this particular circuit diagram. We have connected the circuit as per the circuit diagram, and we have applied input signal by using the function generator, and RPS, VCC we are applying 12 volts, and the waveforms we are observing it. Now I will show the input at this particular point. So this is the input signal you can see in the circuit. At CB, the capacitor CB, we have given the input signal by using the function generator. So the frequency is represented it as 1 kHz signal we are applying. So this is the input signal you can observe in CRO. And if you observe this particular procedure, after applying the input signal and VCC 12 volts we have applied, and VS we need to apply, input signal we have applied already, we are seeing in the CRO. And we need to vary the frequency from 10 Hz to 1 MHz. We can vary the frequency. Slowly we are varying the frequency, and then we are measuring the gain. This is the tabular form we have. So we will vary the input frequency step by step, and correspondingly we are noting the output voltage. Then we are measuring the gain. The gain of the amplifier is measured output voltage to the input voltage, the ratio of output voltage to the ratio of output voltage to the input voltage. Gain is nothing but a 20 log of output voltage by input voltage. You will get in terms of dB. So we are varying step by step. Now 1 kHz onwards we are varying the input voltage. So in order to observe the output voltage, we need to place this particular one at this particular position in the circuit diagram. So this is the output voltage we have. Now I am varying to now I am varying the frequency 2 kHz. So this is the output voltage at 2 kHz signal, 2 kHz sinusoidal signal we have. Like step by step we have to vary the frequency. So this is the 3 kHz signal we have. Like 4, 5, 6,